Okay, so the very next thing that we started to learn when we studied stoichiometry is the concept of molecular weight. Molecular weight and Avogadro's number is a way in chemistry for us to make things a lot more tangible and useful. So Avogadro's number is to basically relate how many individual atoms you have to something called moles. And what molecular weight does is it relates that concept of moles to grams, so we can actually measure stuff out. So molecular weight is something that you have to know how to do because you'll do it a lot when you start actually applying chemistry. So this is going to be the very basic understanding of molecular weight. So for example, we're going to calculate the molecular weight of calcium chloride. Your very first step is to figure out what the heck calcium chloride is. So we know that calcium is Ca, and it's in group 2, so it should have a charge of +2. Chlorine is Cl, and it's a halogen, so it has a charge of -1. So what I'm going to do is I'm going to crisscross, and that way I get the chemical formula. So we have CaCl2. Now for molecular weight, you need your periodic table, so if you don't have one out, pull one out right now. And what you're going to do is you're going to list off each atom and how many of that atom there are. So I have calcium, and there's 1 of them. I have chlorine, and there's 2 of them. And the way that you know is by these subscripts. What you're then going to do is you're going to take that number of how many there are, and you're going to multiply that by the atomic mass. So in the periodic table that I use, the atomic mass is this number in the top left corner, but if you forgot, you have a periodic table map key right here. So for calcium, it's about 40. I'm going to round. And the units for that are grams per mole. So then on my periodic table, I'm going to do the same thing for chlorine. I'm going to figure out what chlorine's mass is, and it's about 35 grams per mole. And so what you're going to do is you're going to multiply out these numbers, and then once you multiply out these numbers, you're going to just add them together. So I'm going to get 40 plus 35 times 2, which is 70. When you add that together, you get 110 grams per mole. And so this is going to represent that relationship between grams and mole. So it's a very important number. So we'll practice one that's a little bit harder. Now we're going to calculate the molecular weight of sodium phosphate. So again, you have to start with writing the chemical formula. Sodium is Na, and it's in group 1, so it has a charge of +1. Phosphate is a polyatomic because it ends in 8. That's your big indicator. So what you're going to do is you're going to go to page 2 of your reference table, and you're going to figure out what the formula for phosphate is, and you should find that it's PO4 3-. So your very next step is going to be to crisscross these charges. So you get Na3 PO4. So now we're going to list off each atom. We have sodium, phosphorus, and oxygen. There are 3 sodiums, 1 phosphorus, and 4 oxygens. So again, you're going to go to your periodic table and you're going to look up the atomic mass for each of these atoms. For sodium, it's about 23 grams per mole. For phosphorus, it's about 31 grams per mole, and oxygen is about 16 grams per mole. So then what you want to do is you want to multiply out these numbers. And then you want to add them all together. So we have 64 plus 31 plus 69 is going to give us a molecular weight of 164 grams per mole.